These pools look like an alien movie set. Neon yellow, acid green, rust orange, rimmed with salt and steaming. But they are real, here on Earth, in northern Ethiopia, at a place called Dallol. The water sits near 108 degrees Celsius, acidic enough to fall off the bottom of the pH scale. Almost nothing can live in it. And yet a short walk away, people are cutting salt from the ground by hand. This is the Danakil Depression, and the reason it looks like another planet comes down to one thing. Underneath it, 3 tectonic plates are tearing apart, letting the inside of the Earth leak up to the surface. So let me show you what is actually going on here, because once you understand the cause, every strange and deadly thing about this place starts to make sense. The heat, the acid, the gas, the lava, and even the people. The Danakil Depression sits in the Afar region of northern Ethiopia, in the Horn of Africa. From above, it looks like a wound in the land, a sunken basin of blinding white salt flats, black volcanic rock, and those impossible colored pools, all of it dropping away below the level of the sea. By some measures, it is the hottest inhabited place anywhere on the planet. The people who have traveled there to study it or to film it almost always reach for the same comparison. They say it looks like the surface of another planet, and that comparison is closer to the truth than it sounds. Because the Danakil is more than a brutal desert. The ground itself is actively coming apart at the seams, right under the feet of the people standing on it. To see why, we have to stop looking at the surface and start looking at what is happening miles below it. The Earth's outer shell is broken into enormous slabs of rock called tectonic plates, and those plates are always moving, grinding, pulling, and colliding by a few millimeters a year. It is slow enough that you never feel it, but relentless enough that, given time, it builds entire mountain ranges and tears continents in half. Most of that drama happens out of sight. New ocean floor, for example, is usually created deep underwater, along cracks in the seabed where plates pull apart and magma rises up to fill the gap. You almost never get to stand on dry land and watch it happen. The Afar region is one of the rare exceptions, and the reason is what sits beneath it. Here, 3 separate plates meet at a single point. Geologists call it the Afar triple junction. On one side, there is the African plate, sometimes called the Nubian plate. On another, the Somalian plate, and pushing up from the northeast, the Arabian plate. 3 plates meeting in one place is unusual enough on its own, but this is what makes Afar truly rare. Instead of crashing together, these 3 plates are pulling away from one another in 3 different directions at once. Picture grabbing a sheet of something and stretching it from 3 corners at the same time. The middle gets thinner and thinner. It stretches, it strains, it cracks, and eventually it tears wide open. That is what is happening to the crust under the Danakil. As the 3 plates pull apart, the ground between them is being stretched thin, sagging lower and lower, and ripping open along huge fractures that run for miles. The Danakil Depression is, quite literally, the floor of that tear. And the pulling does not happen at a single, neat speed. This is a detail that gets flattened in a lot of retellings. So, it is worth getting right. Along some arms of this rift, the land is creeping apart at only 6 to 8 millimeters a year. Along others, the split is moving far faster, around 15, and in places up to roughly 20 millimeters a year. Every one of those numbers sounds almost laughably small, but geology does not work on human timescales. Run those millimeters forward over hundreds of thousands of years, and you are no longer carving out a valley. You are opening an ocean, because that is what this actually is. The crust under the Danakil is being stretched and thinned toward the point where it can no longer stay above the waterline. The Danakil is one of the only places on the planet where you can stand on solid ground and watch a brand new ocean basin in the slow process of being born. In the deep geological future, the sea will find its way in, flood the whole sunken region, and never leave. Which brings us back to all that salt. You might reasonably wonder how a baking hot basin ends up carpeted in white salt as far as the eye can see. The answer is, once again, that same tearing motion. As the basin sagged lower and lower below sea level, It kept dropping close enough to the nearby Red Sea that, again and again over geological time, seawater spilled in across the low ground and pooled there. And then the heat did its work. Trapped in a deep, sunken basin under a relentless sun, that seawater could not drain away and could not stay liquid. It evaporated and left every gram of its dissolved salt behind. Then the connection to the sea closed off. The basin dried out, and at some later point, the water broke through and flooded it all over again. Flood, evaporate, leave the salt. Flood again, evaporate again. Layer stacked on layer, over and over across enormous spans of time, until the floor of the Danakil was paved in thick deposits of salt. So those dazzling white plains are really the dried-out ghost of a sea that keeps trying to return, preserved as solid ground. And as you are about to see, that salt is the entire reason human beings still come to one of the most hostile places on Earth at all. But before we get to the people, we have to talk about the heat. Because nothing about life in the Danakil makes sense until you understand just how hot it really is. And the heat is the first thing that tries to kill you. There are two different numbers that get thrown around here, and people constantly blur them together, which only causes confusion. So, let me keep them apart. The first is the year-round daily average temperature. That figure factors in the cooler nights, the changing seasons, every hour of every day across the whole year, and averages them all out. In the Danakil, that all-day, all-year average sits at around 34.4 degrees Celsius, about 94 Fahrenheit. And that average, low as it might sound for somewhere this notorious, is the highest of any inhabited place ever measured on Earth. No other place where people actually live stays that warm, that consistently, around the clock. The daytime, though, is a completely different experience. When the sun is up, the air routinely sits at around 48 degrees Celsius, which is roughly 118 Fahrenheit. And on the worst days, it climbs to about 55 degrees, around 131 Fahrenheit. That is well past uncomfortable. That is heat that can kill an unprepared person in a matter of hours, especially anyone doing hard physical labor out on an open, shadeless salt flat. So why is it this extreme? Part of the answer is simple geography. The basin sits so far below sea level that air sinking down into it gets compressed, warms up, and has nowhere to escape. So it pools there like water in the bottom of a bowl. But the other part of the answer points straight back to the tectonics. Remember, the crust here has been stretched thin, and hot molten rock from deep inside the earth is pushing up unusually close to the surface. The Danakil gets cooked from two directions at once. The sun bakes it from above, and the planet itself heats it from below. And that heat from below is exactly what creates the alien pools we opened with. At Dallol, a body of magma sits close beneath the thin, fractured crust, and it works like a giant underground stove. Groundwater and ancient trapped seawater seep downward toward that heat. As they sink, they get superheated, and they start dissolving metals and salts straight out of the surrounding rock, turning into a scalding, mineral-loaded brine. That brine then forces its way back up through the cracks and comes boiling out at the surface. As it hits the open air and cools, the dissolved minerals crystallize out, slowly building the surreal terraces, ridges, and pools that make Dallol look the way it does. All of it glowing in shades of yellow, green, and orange. For a long time, people assumed those vivid colors were mostly sulfur, but a detailed chemical study of the site found something more specific, and frankly, stranger. A great deal of that color is actually driven by iron, oxidizing the instant the iron-rich brine meets the oxygen in the air. In other words, a lot of what you are looking at is essentially rust, painting itself across the landscape in real time. The water feeding these pools sits at around 108 degrees Celsius, and it is fiercely acidic. The pH scale you might remember from school runs from 0 up to 14, with the strongest acid sitting near the bottom. The water at Dallol measures below even that, around negative 1.7. That is what it means to fall off the bottom of the scale, the off-the-chart acidity from the very start of this video. Boiling hot, that corrosive, and saturated with metal, Dallol is one of the most extreme natural environments ever studied anywhere. And it exists for a single underlying reason. The interior of the Earth is leaking up through a crust that has been pulled too thin to keep it contained. The ground here is dangerous, so is the air. Beyond the heat and the color, a landscape this riddled with volcanic vents and boiling hydrothermal springs also breathes out gas. Reporting from the region describes pockets of toxic fumes drifting around parts of the Danakil, including hydrogen sulfide, the gas that smells like rotten eggs, and chlorine vapor, both of which can be dangerous, and in high enough concentrations, even deadly, to breathe in. And there is a particular reason that matters in a place like this. Many of these gases are heavier than air, so they tend to sink and collect in exactly the low, still hollows that riddle the basin floor. You cannot always see them, and you cannot always smell them in time. In a place where the chemistry on the ground is already this hostile, an invisible pool of gas settling into a dip in the terrain is a genuine, practical threat to anyone walking through it. If this is the kind of place you actually want to understand and not just stare at, then that is the whole reason this channel exists. We take the planet's strangest, most hostile corners and explain the forces working underneath them. So if that is your thing, consider subscribing. It genuinely helps. Now for the single most spectacular thing in the entire Danakil. Rising out of the desert is a low, broad, dark volcano called Erta Ale. From a distance in daylight, it honestly does not look like much. A long, low ridge of black rock under a hazy sky. But at its summit, hidden inside a pit crater, it holds something that almost no other volcano on Earth can hold for any length of time. An open lake of molten lava. Stop and think about how rare that actually is. When magma reaches the surface, it normally erupts in a burst, then quickly cools, hardens, and seals itself over with a crust of solid rock. A volcano that keeps a pool of liquid rock exposed at the surface, glowing, churning, and bubbling for years and even decades on end, is one of the rarest things in all of geology. At any given time, there are only a small handful of these long-lived lava lakes anywhere on the planet. Erta Ale is one of them, and it is among the most persistent of them all. So why does this one stay open, when almost any other volcano would crust over and go quiet within days? The answer, yet again, traces straight back to the rift. Because the land here is being actively torn apart, fresh magma is constantly being fed upward, not just through a single central pipe, but through cracks and thin, sheet-like intrusions that force their way into the splitting crust. That steady delivery of new heat from below is what keeps the lake alive. The molten rock at the surface is constantly losing heat to the cooler air, but it is constantly being topped up from underneath, and the lake keeps churning and convecting as the two balance out. In plain terms, Erta Ale stays molten because the planet is splitting open directly beneath it, and that split keeps the furnace fed. And there is a deeper connection still. Researchers studying the lava lake have asked whether its behavior, the way the level rises and falls, the way its activity surges and calms, is tied to the larger movements of magma and tectonic stress across the whole region. The lake, in other words, may not be an isolated curiosity bubbling away on its own. It may be a kind of pressure gauge, a visible readout of the vast tectonic machine working underneath the entire Afar region. Today, scientists keep watch on Erta Ale partly from space, using satellites that can pick up the heat signature of that lava from orbit and track when it flares up or dies back. And that is really the best way to think about this place. Erta Ale is, in the most literal sense, a window, a glowing hole in the surface of the planet, through which you can look straight down into the molten machinery of the Earth itself. So by now the picture is complete. Killing heat, acid pools, poison gas, and an open lake of lava. Every instinct in your body says this is a place no human being should ever set foot, let alone settle. And yet people live here. They always have. Which finally brings us to the real question. This whole video has been circling from the very first pool of acid. Why? Why would anyone choose to build a life in the single most hostile corner of the continent? The answer is sitting right there on the ground, in plain sight. Salt. The people of the Danakil are the Afar, and for generations they have mined these salt flats by hand. Out on the blinding white surface of a salt lake called Lake Assale, Afar workers break the hard crust open with simple hand tools and axes, lever up slabs of raw salt, and trim them down into neat standardized blocks. Those blocks have a name. They are called amole, and the trade in them has underpinned the Afar economy for a very long time, far longer than any modern road or national border. Getting that salt out of the basin and to the people who want to buy it is its own extraordinary feat, and it produced one of the most striking traditions anywhere in the world. Long caravans of camels, roped together and loaded with stacked salt blocks, set out from the salt lakes and walk for days, climbing out of the lowest, hottest desert on the continent and up toward the cooler highlands, where the salt is sold and traded on. Picture the scale of that for a moment. Men laboring in temperatures that would put most of us in a hospital bed, cutting and hauling blocks of salt out of a lake bed that is, remember, the slowly forming floor of a future ocean. And that is the answer to our question. People do not live in the Danakil in spite of the conditions that make it so deadly. They live here because of them. The very forces we have spent this whole video describing are what created the prize. The tearing earth sank the basin. The sea flooded in. The relentless heat baked it dry. And in doing all of that, it laid down an enormous, renewable fortune in salt. The exact same geology that makes the Danakil almost unlivable is the geology that gave human beings a reason to stay and endure it. But that ancient way of life is changing fast right now, and the cause is almost mundane after everything else we have talked about. Roads. For most of recorded history, the only way salt left the Danakil was on the back of a camel, one block at a time, at walking pace, across the open desert. Then, from around 2010, something simple began to change all of it. Trucks started arriving at the salt lakes. A single truck can carry in one trip what used to take a whole caravan of animals and days of brutal walking. And it can do it faster and far more cheaply. Behind the trucks came new tarmac roads, pushing deeper into a region that, within living memory, you could only cross on foot or on hoof. For the Afar, this is a genuine turning point. Researchers who have spent long stretches, more than a year of fieldwork, living and working alongside the salt miners have documented an entire economy quietly being remade in real time. The camel caravans, the very image that has defined this place for outsiders for centuries, are slowly fading from the landscape. The salt itself is still being cut by hand, out on the same blistering flats, in the same brutal heat. But more and more of it now rides out of the desert on wheels instead of on animals. And as the camels go, a whole way of life, an entire culture built around those long desert crossings, is quietly slipping into history. So step back and try to take in the whole thing at once. The Danakil Depression is something far rarer than the harshest desert human beings have somehow managed to cling to the edge of. It is a ground-level view of an event almost no human ever gets to witness directly. A continent splitting in two, and a brand new ocean beginning to pry itself open along the tear. The acid pools, the poison air, the lava lake that never goes out, the killing heat. Every single one of them is a symptom of the same deep event happening below. 3 tectonic plates, pulling apart in 3 directions, stretching and thinning the crust until the molten inside of the planet starts to show through to the surface. And living right on top of that seam, in the most inhospitable corner of it, are people who took the byproduct of all that geological violence, ordinary salt, and turned it into a way to make a living and survive. In the far geological future, long after every one of us is gone, the sea will win this slow contest. It will flood across this sunken, splitting land, and the Danakil as we know it will vanish completely beneath a new ocean. But for now, for this brief window in the planet's history, it sits open to the sky. It is one of the only places on Earth where you can stand on the surface and watch the world in the act of rebuilding itself. If you want to keep exploring places like this, places that look impossible until you understand the forces working behind them, then stick around, because there are far more of them out there than you would ever think.